Okay, let's start with section looking ahead 5, multiplying two binomials. Multiplying two binomials is similar to multiplying a binomial by a monomial, but there will be twice as much distributing involved. For example, if I wanted to multiply x plus 2 times x plus 1, I would have to multiply both terms of this first binomial by each of these two terms. So for example, I could first multiply x times x plus 1, and then I would multiply 2 times x plus 1. Well, and then to multiply these, we know this is a monomial times a binomial, so we know to just distribute. So that would be x squared plus x plus, and then distribute the 2, 2x plus 2. And then of course we know from here that these two are like terms, so we could combine those to get x squared plus 3x plus 2. But this was a very simple example, and you can see how much distributing is involved already. So we have a clever little acronym here that helps you keep track of each of the terms when you're multiplying two binomials. It basically ensures that each of the terms has been multiplied by each of the terms in the first binomial has been multiplied by each of the terms in the second binomial. Nothing's been duplicated, nothing's been left out. So this acronym is FOIL, F-O-I-L, and that stands for multiply the first terms, multiply the outer terms, multiply the inner terms, multiply the last terms. So if we use our same product of two binomials here, the same thing we used up here, we see when we multiply the first term in each binomial is x. So x times x is x squared. And that's what we got right here, x squared. When we multiply the outer terms, that's x and 1, the ones that are on the outside. X times 1, which is x. And that's what we got right here. X times 1 was x. And then when you multiply the inner terms, that's the two on the inside, the two closest to each other. So here that's 2 and x. 2 times x is 2x. And that's what we got here, 2 times x was 2x. And then when we multiply the last terms, the last one in this binomial is 2, and the last term in this binomial is 1. So 2 times 1, which is 2. And again, that's what we got here. So now when we add these together, we know that these two are like terms. We can combine those to get 3x. So x plus 2 times x plus 1 is equal to x squared plus x plus 2x plus 2. Or if we combine these two, x squared plus 3x plus 2. It's the same thing we got up here. So this just allows you to do maybe a little bit more of the work in your head without having to write out this step. All right, so let's see what this looks like in some examples. So for each of these, we want to multiply. For the first one, we're multiplying x plus 3 times x plus 4. And I'm going to write out the acronym. Normally you wouldn't write this out, but this at least allows you to see where each of those products comes from. So we first multiply the first terms in each one. So that's the x in this one and the x in that one. And x times x is x squared. And then O is the outer terms. So x and 4. X times 4 is 4x. And then I for the inner terms. That's these two. 3 times x is 3x. And then L for the last terms. The last one here is 3, the last one here is 4, and 3 times 4 is 12. All right, and we always check for like terms. So we have like terms here. So we'll combine those to get x squared plus 4 and 3 is 7. So 7x plus 12. And that is our finished product. Okay, let's do the same thing for this one. So f for first, which is 2x times x, That's 2x squared. O for outer, 2x and 3. 2x times 3 is 6x. I for inner, that's these two. 1 times x is x. And L for last, that's 1 and 3. 1 times 3 is 3. And then we'll combine like terms here. We have 2x squared plus 7x plus 3. Okay, and you might be starting to notice that pretty much every time we can add the O and the I, the outer and inner pairs, those give us like terms. Same thing here. That'll be true every time you have the same variable in both of these and the two binomials look the same, meaning that they have the variable term and then the number without the variable. Variable term, number without the variable. Same thing here. Variable term, number without the variable. Variable term, number without the variable. So when that looks like that, those two middle terms will be able to be combined. All right, let's do one more together. Okay, so for the first, we have 3x and 2x. 3 times 2 is 6. X times x is x squared. So this is 6x squared. O for outer. That's 3x and minus 3. Make sure you remember that this negative applies to this 3. So if you need to, you can actually change this to plus a negative 3 to remember that that belongs to the 3. So we multiply those. 3x times negative 3 is negative 9x. The inner I, 2 times 2x is 4x. And the last L, 2 times negative 3 is negative 6. All right, and again, those middle terms are like terms. So we have 6x, and then negative 9 plus 4 is negative 5x minus 6. Okay, so there are three try-it-yourself problems for you to do on your own. Pause the video, work those out, and when you're ready to check your answers, press play. Okay, for these you should have gotten, for A, you should have x squared plus 5x plus 6. For B, 2x squared plus 5x plus 3. And for C, 2x squared plus 16x plus 24. Okay, that is it for looking ahead 5. So let's go on to looking ahead 6. Dividing a polynomial by a monomial. So now we're dividing. The last couple sections we've been multiplying. This time we're dividing. So we're just going backwards basically. So to divide a polynomial by a monomial, we divide each term of the polynomial by the monomial. So when we see something like example 1, A, where we're dividing these two terms of this polynomial by this single monomial, all we have to do is divide each term separately by this monomial. So we'll take the first term, the 10x squared y squared, and we'll divide that by 5xy. And then we'll take the second term and divide it by 5xy. And then we'll simplify each one separately. So here we have 10 divided by 5, which is 2. X squared divided by x. Remember, we subtract exponents here because we're dividing. So this is 2 minus 1 is 1. So that's just x, or x to the first. And then the same thing here, y squared divided by y, subtract the exponents, 2 minus 1 is 1, which would give us just y. And then here we can see that these all are the exact same thing. So 5 cancels with 5, x cancels with x, y cancels with y, and this leaves us with the exact same thing on the top and bottom, just 1. And if it helps to just kind of take a step back and look at this, you have something divided by itself. Of course, this would be 1. And now this is completely simplified, and that is our answer. Okay, let's do another one. So here we have, again, 2 separate terms in this polynomial, and the whole thing is divided by 3. So we'll take the first term, 27x squared, and divide it by 3, and then take the second term, 21y squared, and divide it by 3. Here, when we divide 27 by 3, we get 9. So that's 9x squared. And here, 21 divided by 3 is 7y squared. And those can't be combined or anything, so we'll leave this just like that. Okay, there are 2 try it yourself problems for you to do on your own. Pause the video, work those out. When you're ready to check your answers, press play. Okay, for A, you should have gotten 4A minus 2. And for B, 5x plus 3. Okay, one more example. Example 2 says the perimeter of an equilateral triangle is 18x squared plus 6x. What is the length of one of its sides? Well, what do we know about the perimeter of a triangle? Well, we know that a triangle has 3 sides. We also know that this particular triangle is equilateral, which means that all 3 sides are equal. And when we find the perimeter of a triangle, we add all 3 sides. So here I have added whatever the length of one side is. I have added that same length 3 times to get 18x squared plus 6x. So if I want to know what the length of one side is, I just need to divide this perimeter by 3. So I have 18x squared plus 6x divided by 3. So let's take each term of this polynomial and divide each one by 3. Okay, so we have 18x squared divided by 3 plus 6x divided by 3. And here 18 divided by 3 is 6. Bring down the x squared. And here 6 divided by 3 is 2. Bring down the x. And that is the length of one side. Alright, there's a try it yourself problem here for you to do. Pause the video, work through that problem. It's very similar to this example. And when you're ready to check your answer, press play. Okay. Oh, no idea what that was. Okay. So the answer you should have gotten for this, the length of the garden should be 2x plus 3. All right, and that is it for section looking ahead 6.